We can start, right, Rupa?
Yes, sir.
Okay. Hope you're able to see my screen. Good evening, all. So, welcome to VLSI Physical Design demo. So, in today's demo, so I was going to cover about a complete VLSI Physical Design course. And before that, I will give some of the details about our institution, and then I will show the how the work-life balance and how is the career growth in VLSI Physical Design field. And later, we will see some of the placement reports, and then we will discuss about the what are the different modules we are going to cover in the VLSI Physical Design course. Okay. Coming to our institution, so we are the one of the best VLSI institution in Bangalore and Hyderabad. Or let me mute everyone.
Yes.
Okay. So coming to our institution, so we are the one of the best VLSI institution in Bangalore and Hyderabad for both freshers and working professionals. And we are going to provide advanced VLSI studies, and that will be 100% placement assistance. And these placement assistance will be there until you are going to get placed. And we have industry standard EDA tools, and the tool and lab support will be 24 by 7. Coming to the faculty, so the faculty and trainers here we have, so they have minimum 15 plus years of experience in the semiconductor domain. So since they have 15 plus years of experience, so we might done a lot of tape outs, right? So there is a lot of learnings. So whatever the learnings we have in our real-time projects, so we are going to add those into our labs so that you will get the proper knowledge. And we have very good collaboration with almost 100 plus signing companies, and we are also going to provide 100% placement with train material, and also will conduct a mock interviews once you complete the course. I will show the companies in the coming slides. Okay. And we have a proven track record of placement with scholarship at as well. And this is a question rises, right? Like why you need to choose Akshavasi technologies. So these are the unique features I can say. So the first and very important one is the placement assistance. So we are going to provide 100% placement assistance, and this placement assistance include your mock interviews, and we will also take care of your feedback from the client, and we will arrange some interviews, everything included. Okay. And tool also will be there until you are going to get placed. The other one is the course curriculum. So this is the industry standard course curriculum, we can say. So why it is industry standard? So because our students so are going to start working from day one. Okay. So company no need to put any additional efforts to train them separately. So our students are going to start working from day one. That's the reason our clients are very much interested into our placements. Okay. So whenever they need resources, so they will simply mail us, like they need 10 position, 12 position. Okay. Accordingly, so they might call in, introduce to their organization. Sometimes they will visit our institution. So they'll take, okay. So based on the technical feedback, and the lab support, 24 by 7 lab support will be there, and the course fee will be low value for the money which you are paying. Okay. So I'll play one of the corporate video so that you will understand our institution, classrooms, lab, and all other infrastructure. Okay. Just give me a minute. So let's go back to our presentation. Okay. So yeah, just now you have seen right our lab and infrastructures, and so we have dedicated lab and classroom and dedicated server room so that you people won't see any issues with respect to VPN connectivity. Okay. So this is our Bangalore office. So coming to the course information. So in today's demo, I was going to cover complete course information, like what are the different modules we are going to cover as a part of VLSI physical design. And if you want to look into it, like you can visit our website. There also will found the physical design course details and mode of study. So we have two modes, offline and online. Online we have both daily and weekend batches. So these weekend batches, especially for the working professionals, so they want to switch to software or some other domain to PD. So for them, we introduce the weekend batches as well, and the duration will be 5 months. Coming to the tools, so for PNR activity, place and route activity, so we are going to use a Synopsys IC compiler, and for prime time, we are going to use it for the timing sign off. Okay. And as I told earlier, so we are going to provide 24 by 7 VPN access to the tools. And coming to course, this course material. So for example, if you're now online, so this material will be courier to your address. For offline students, you can collect at our institution. Coming to the eligibility, so who are eligible to take VLSI physical design course? So either you might completed or pursuing BTech or MTech in any of electronics stream, so we're eligible for the VLSI physical design. Okay. Or if you are working professionals in other domain like DFT, Verilog, right? If you want to switch to PD, so you are also eligible for the VLSI physical design course. Okay. So the very important, like whenever you are planning to choose any course, okay, either it will be VLSA or non-VLSA, you have to keep two things in mind. Okay. So one is how is your financial growth, and the second one is how is your career growth. So both you have to choose. For example, if you have only financial growth, you cannot work more than few years, right? So only after 5 to 6 years you get bored of that job and you won't see any challenges, right? So similarly, if you have a very good growth in career and there is no financial growth, so there also you won't survive. Okay. So in VLSI industry, especially for physical design, as a fresher you can expect 4 to 6 LPA. So these are the minimum salaries or base salaries, minimum base salaries you can consider. So we have seen a few of our students, they got a 20 LPA and 12 LPA, okay, as a starting salary. I will show in the coming slides. So we have captured that. And so once you get T plus years of experience, right, so your salary will be 15 to 20 LPA, and you'll also get good product based companies also. So once you place into product based companies, along with the salary, you'll also get stocks. Okay. And after 5 years, you can see yourself as a team lead position, and your salary will be 25 to 30 LPA. So similarly, after 10 years, you can see yourself as a program manager or team manager. So your salary will be 60 to 80 LPA. Okay. So all these are the minimum numbers I had quoted. Okay. You can even get more than this easily. And placement support, as I told earlier, we have very good collaboration with almost 200 plus hiring companies. So these hiring companies include product based companies, so which majorly deals with the product development, and service based companies and startups as well. So these two will provide services to the product based companies. And we have very good collaboration with top MNC companies like L&T, Capgemini, Wipro, Saint, Synapse, and all. So I was getting some background noise. Let me mute that guy. Okay, Nandu I had muted, Ashwini I had muted. So okay, sorry for that. And so we're talking about placement support, right? So and we are also going to give complete support of tool and interview until you are going to get placed. And as I told earlier, 4 to 6 is the minimum package. So these are the companies I was talking about. If you see this list, so you can see here, right? Product based companies like Broadcom, Qualcomm, okay, and Western Digital, Cadence, okay, Invicus, okay, just 1 minute, okay. So and top MNCs like Wipro, okay, Capgemini, and we have very good collaboration with startups as well, like Apex, okay, SI2 Chip, Radiant. So we have very good collaboration with all these companies. I will show the coming slide so that you will understand our student got placed into all these list of companies. Okay, so you see, so these two people recently they got placed into Cadence, and these people got placed into XLBSA. These are the recent batch, and you see, these people got placed into Silicon Semiconductor, Bit Silicon, and these people got placed into Lead IC, okay, Blueberry, Synopsys, Insemi, Synapse, right? And these people got placed into Keenheads, Onsemi, okay, Thinsil, AMSC, Capgemini. So if you see this list, right? So whatever the companies we have good collaboration, no? So you can see all those companies here, right? So these people got placed into TrueChip, Smart Smoke, and Savitech, right? And Maven Silicon. So Maven Silicon is the company. So basically, they'll provide on-site opportunity as well. So our student recently they went to Singapore and Japan. Okay, and these are the few more placement report. So as I told earlier, like 4 to 6 is the minimum package. So one of our student, she got placed into onsemi, and she got 20 LPA as her annual package. And other student, she got placed into Micron, and 12 LPA was her package. Okay. So yeah, so these are the few more placement reports. So these people got placed into Capgemini and Apex, Semi, Wafer Space, and these are the few more placement report. Yeah. And yeah, you can see all this placement report. You can even visit our website, and you can go to the LinkedIn page. There also you'll found all this info. I was not spending much time on this placement because we need to cover very important thing, that is course curriculum, right? So you need to understand what are the different modules we are going to teach. Okay, here for the complete 5 months, what you are going to learn. So coming to the course curriculum, so as I told earlier, right, so it is the industry standard, right? And also what we have done, we have started, okay, from basics, some introduction to different modules, and then PD and sign off and HT also we have included. Okay, so this include like 13 modules. Okay, so we'll discuss about each module, okay, in detail in the coming slides. Yeah. So the first module, which is Introduction to Electronics and MOSFET and CMOS theory. So what we will cover in this module? So in this module, we will cover basics of analog electronics and MOSFET basics. Also, we'll discuss about the fabrication flow of CMOS structures and layers of fabrication. So these layers of fabrication is not same, like for different technology. So we have different layers for 3 nanometer. So the number of layers will be different, and DPT layers will be different, and the fabrication process also different, right? So everything we are going to teach in terms of whatever happening in industry. So current days, okay. So based on the latest technology and latest node, so we are going to cover this complete module. Okay. So the second module is the digital electronics. So this covers all your basic Boolean algebra like K-maps, combinational circuits like adder, subtractor, and all even like basic gates also will cover. Okay, and also will cover sequential circuit, flop, synchronous. So it is not same as your academic basically. Okay, in your academic what you might done, you have taken one problem, you have done something, right? Only in the labs you have done some design part, but here it will be design oriented. We will give some design, we'll ask you to do some simplification, and you have to design. Okay, so with this you will understand the design part also. So how to design like for bit synchronous down counter or up counter, okay, like this. And the next module will be the basics of Unix and Linux environment. So whatever the activity you are going to do, right, in the next coming 5 months, okay, everything will be using this Unix environment only. So in this module, we'll introduce the Unix working environment and the different commands to do operation in the Linux, okay, and also we'll introduce tool here, okay. So whatever the tool we are going to use, that will introduce the third module itself. Why? Because so we want our students has very good hands-on on the tool. Okay, and these are the basic examples of Linux command. For example, if you use Windows, right, if you want to copy, you might use some shortcut, or you can use, right, so right click and copy and paste. So for in Unix you have to use cp command. Okay, cp, source file and destination file, it will copy. If I want to copy the directory, nothing but the folder, Okay, I need to use cp-r. Okay, similarly, if I want to rename, I can use mv command. Mv new file name, okay, which is existing already, and new file name, okay, so that it will rename again. So these are the basic commands. Along with that, we are going to teach some vmatter command, awk and set languages. Also, even though we not included in the module, we'll teach tickle scripting also in the third module itself. Okay, so the next one is the ASIC flow. So this is very important module. So after this module, you will understand what is ASIC. Okay, how the for example, you are using mobile, right? So there is a chip inside your mobile. You don't know how it was evolved, right? So it's basically start from specification. That means like, okay, so the specification is like we have to design a chip with this functionality like gpu, and the frequency will be this much, and that means speed is this much, and power consumption is this much, and dimension of the chip will be this much. So this comes into the specification. So based on the specification, you have to decide which architecture you want to go. You either you want to use like blackwell, you want to use like arm. So there are different architectures. So you have to choose some architecture, and then accordingly you need to write the RTL code, okay, in a Verilog. So there is separate team will be there, okay, architecture team will be there, RTL team will be there. So they will write Verilog code and they will test it, and after it will go to the synthesis. Okay, once synthesis is done, it will go to DFT, and then it's all the physical design flow. So we will in the coming slide I will cover like what is synthesis, DFT, everything I will cover. Okay, so basically just understand this part is the front end and this part is the back end in a VLSI. Okay, front end include a specification, architecture, and RTL design. Okay, sometimes we call synthesis and DFT also front end, and sometimes the back end team also will do synthesis. Okay, from foreplan to this chip finish, we can consider the back end. Okay, and the next module is introduction to Verilog. So, uh, truly speaking, as a PD engineer, you are not going to write any Verilog code, but we still added this module. Why? Because so we want our student have some complete end-to-end idea, because whenever there is a cross-function meetings, okay, so you need to understand what that RTL guy was discussing. Okay, so they might discussing like one tick B, one tick B, not like that. Okay, you need to understand what is that one tick B, right? So that's the reason we have added this module. So we won't spend lot of time here because it's just introduction part. So in this module we will cover some introduction part and some Verilog syntaxes and some examples. Okay, so we will take some logic and we'll try to write the Verilog code for that, and FS implementation and different coding styles of RTL. So the all these things we are going to cover in the fifth module. And the next one is a DFT. So DFT is nothing but design for testability. So basically we have our chip, right? So we have to test that chip, because we need to make sure that, because without testing, if you insert that chip into your mobile, okay, so for example after uh, installation that chip is not working, what you will do, you cannot send your mobile to crash, right? You have to verify it. Okay, so to do that we are going to add some extra logic. Okay, so that extra logic we are going to put in our PD process or physical design process. Let's say at placement stage we are going to add this extra logic. Okay, so this extra logic adds an extra feature of our IC. Okay, what is that extra feature? That is testability feature. So it will add additional feature which is testability feature to our IC. Okay, this we don't need to write anywhere this DFT code and all. So separate DFT team will be there, so they will write and they will give that DFT logic. Okay, so why we need to insert this DFT logic? For testability. So why we need to test it? Because so whatever the post production process we are using, okay, our manufacturing process, it is not 100% error free, because there is lot of machinery involved. Okay, so if you I hope all you might aware of the foundries and all, right? So there is lot of take cares need to be taken, but still there will be some defects in the silicon, or there will be some defects in the physical devices, so which leads to damage of your chip RIC. So we have to catch it. So if it is not working, you have to trash it. If it is working fine, then only you can take and give to your end user, which is mobile or laptop, whatever. Okay, and the next module is synthesis. So basically, synthesis is the process of converting specification of circuit behavior to the RTL. So this circuit behavior code we will write basically. Okay, RTL guy he will write the this code in circuit behavioral language. So what we will do, we will take that code and we will give some constraints and we will give some optimization settings, and then we will use the tools called DC compiler. So this DC compiler is an example from Synopsys vendor, and there is other tool which is Genus, that is from Cadence vendor. So with the help of these tools, we are going to optimize the design. Okay. So after that, we'll get the technology specified gate level netlist. Okay. So this technology specified gate level netlist we are going to use to the further PD process, which is import design, for planning. So for all those things, we are going to use technology specific gate level representation or netlist. Okay. So in the synthesis, we are also going to cover different optimization techniques. Okay. And what are the timing constraints, exceptions, design rule constraints, and constraints at interface level, and how to validate the quality of synthesis. Everything we are going to cover in detail. Okay. And the very important modules are HTA. Okay, so since HTA is very vast, we have divided into two parts. Okay, in the eighth module, we majorly discuss about the basics. Okay, so what is a setup, whole, all these basics. In the ninth module, we will go with advanced topics and some designs also. We'll take some design and we'll try to fix setup, and we'll try to calculate everything we'll do. So basically, what is HTA? HTA is a method of analyzing, debugging, and validating the timing performance of a design without simulation. So since we are not going to simulate it, so if you see the properties of HTA, it was faster than GLS, okay, gate level simulation. And here we are not going to check any circuit functionality. So we have in sign off, I'll show there is a step called formality. So there we'll check the circuit functionality, and vector generation also not needed. So with all this, it will be become faster. Okay. So how HTA will calculate the complete delay? For example, if you have a circuit, okay. So let's say there is a circuit. In the circuit, there is an AND gate. Okay. So what it will do? It will take the delay of AND gate, and it will take the wire delay. So it will add both wire delay plus AND gate delay or device delay together. It will get the complete path delay. Okay. That's how it will calculate the complete path delay. And if you see in ASIC flow, so we'll perform HTA at synthesis stage, and HTA at before starting PNR, we will do HTA. This is basically we called zero wire load model analysis, because here we are not don't have any wires or physical connections between two pins. Okay, so once you have CTS, we will do HTA and estimated parasitics. After routing, we will do HTA and actual parasitics. So this parasitics is nothing but your resistance and capacitance of a wire. Okay, so in the coming slide, I will cover what is CTS, routing, placement, all things I will cover. Okay, so the next module and major module was the physical design flow. So in design cycle of VLSI chip, so it consists of different steps, like from high level synthesis to the production. Okay, so in that, physical design is one of the step. So if you see the physical design, it is a process of transforming a circuit description into the physical layout. So this circuit description is nothing but your Verilog code. Okay, synthesized Verilog code that you are going to convert into the physical layout. So this physical layout describes the position of the cell and routes for the interconnections between them. Okay, so the main objective of the PD engineer is to generate the layout with minimum area, or you can simply say PPA, power, performance, and area. If you take any electronic device, okay, smart device nowadays, so just compare from last 5 years, right? Your power consumption should be less, okay, and performance was higher. And what about area? It was very compatible, right? So all these things day by day was happening because of the PD engineer. So if you see like 10 years back, how was your mobile or laptop? Okay, assume in terms of PPA. Okay, power consumption, obviously it is high. Performance, it is low earlier. Now it is very good, right? And area, it earlier it was very big to carry on. Now it is very compatible and smart devices, right? So all this because of the PD engineer. Okay, and so since it is a very big module, now what we have done, we have divided into five sub modules. Okay, each sub module. So what we have planned, first we'll discuss about the theory part. So immediately we are going to conduct the lab. Okay, so whatever you have learned theoretically, so those you are going to implement in the lab, so that you will understand in a better way, right? So if you see the inputs of the physical design, so one is the gate level netlist. So this is what we got from the output of synthesis, and this is the constraints. Constraints is nothing but your clock frequency and all other rules and all. Okay, so logic and physical libraries. So this you got from the foundry like TSMC or Samsung foundry, whichever you choose to deliver the chip, right? So from there you will get. And def. So this def contains your chip dimensions. And scan this scan-def contain DFT logic, so which you get from the DFT team. And UPF. So if you're working on multi-voltage domains, then you need UPF. If you're working on single voltage, you don't need any UPF. Okay. And so this is a snippet from IC compiler. Okay. So you see the area inside this box, so where I can see you can see this, right? So this we call as the core area. Okay, so these all are the macros or IPs. So each macro or IP is having some functionality. Okay, so and all these dots you can see, these are we can call it the standard cells, nothing but your AND gate, OR gate. Okay, and your flops, everything. So at input design stage we just loaded all the inputs. Okay, so in the next step what we will do, we'll place these macros inside the core area. That is called floor planning stage. In the next step, we'll do placement, standard cell placement. So all these standard cells we are going to place inside. Okay. And after we have CTS. And in CTS, we'll do clock tree synthesis. And then I have routing. Okay. That's how it will be. And in the lab, what we will do, right? So what are the inputs you have seen? Okay. Sorry. So these inputs, right? Everything will be loaded with the help of command. For example, netlist. There's a set of commands will be there. Read netlist. So all these commands we are going to put in this Tcl file, and then you are going to source it. That will load all the inputs. And after you have to validate whatever the inputs you have loaded, those are proper or not. There are some set of commands like check timing, check design. So it will report if there is errors. If there is errors, you have to report back to the guy. For example, if there is errors to related to your netlist file, okay, you have to report to this guy, RTL guy. Okay, if there is error related to libraries, you have to report to the foundry. Okay, like that. And the other one is the scenario creation. So basically, uh, you see you are using your mobile. Okay, sometimes you are traveling to some extreme low temperature conditions, and sometimes you are traveling to extreme high temperature conditions, right? So you expect your mobile should work properly in all temperature conditions, right? So that you have to create, and you have to do this here in the scenario creation. So what we will do here basically, so we will decide, for example, if it is a military rated thing, okay, we should work under extreme low and extreme high temperature. Or if it is home appliance, so there will be some, for example, what we will do here. So this chip should work from -40 to plus 40 degrees centigrade. So those there are different stuff scenarios will be there. That all scenarios we are going to put in scenario.tk, and then we are going to source it. Okay, accordingly we are going to optimize in the coming stages. And start with the command. So if you run this command in the shell IC compiler, you can see like this. Okay, so the next one is a floor planning. So basically there are two type of floor plans. One is a full chip and the other is a block level. Okay, so you people most of the time going to work on block level. Okay, and there are different goals. Okay, so for full chip guy, you have to estimate the die size by minimizing the core area. Why you need to estimate by minimizing core area? Because it is your one of the target, right? PPA area, right? And you have to plan a way to place different IPs like USB, video, display, DDR, and all. Because for example, there is a display and audio. So there is a lot of connections between display and audio. So what you need to do, you need to place these two IPs near to each other, so that you will reduce the wire length. Okay, and you have to plan your IO pads. Okay, and you have to do proper power planning. These are the full chip goals. Coming to block level, you have to plan your macro placement, and you have to decide the between the macro there is some space. Okay, so this one, so this space we call it channel. So you have to decide the channel. Okay, how much channel you have to give, and around the macro you have to provide some halo to avoid some DRCs. Okay, which is a foundry requirement for better yield. Okay, and there is some rules. Okay, maximum allowable length of macro stack, so that you have to follow. And IO port planning, row creation, power planning, all these goals you have to meet. And you see, this is the block diagram. Okay, so this is the full chip block diagram. This is the core area, and this is your ground and power rings. All outside these are your IO pads. So if any external connection, for example, let's say uh, power, okay, so there is a voltage regulator which is outside. So from voltage regulator it will come to the pads, power pads. From power pads it will come to the power rings. From rings, with the help of stripes, it will go to the core. Okay, so what will be there inside the core? Your standard cells. Okay, simply you are taking supply from voltage regulator and you are placing it here. Similarly, clock. So you know PLL is a clock generator, right? So there will be PLL outside. So with that PLL it will generate the clock. So that clock will come to the pad. From pad to this core area. Okay, so since this is a core dominant, no? So we are calling it as a core limited design. If the pad area is more, so we can call it as a pad limited design. Okay, so this is the lab section. So now you see, in earlier module import design, all macros are here. Now at for planning and power planning stage, we have placed it properly. So there is a lot of analysis we have to do. Blindly we cannot place this. So we need to check the color hierarchy, which family belongs this macro belongs to, and you have to check the fly lines also. Okay. So all you have to check and you have to place accordingly. So what we will do, will help you to understand the fly lines and will help you to the foreplan. And also in the same module will help you to understand different sections in the GUI, like what is the menu bar, what are the different options, right? And toolbar and some settings. Okay, all these things we are going to explain in the second module. Okay, and the next one is placement. So now you have done the macro placement. Now you see outside dots. Now these are the standard cells like your AND gate, OR gate, and flops. So now you have to place this. So that will be going to happen in the placement stage. So again, you have placement goals also. Okay. First of all, discuss about what is placement. Okay. Placement is nothing but placing the standard cells inside the core area in a given location. Okay. So who will give this location? So there is an internal algorithm in the tool. Okay. So based on algorithm, it will place inside the core area. Okay. So while placing, it cannot place blindly. For example, you are going to read the netlist, right? So there is a connection between AND gate and OR gate. So these two are going to place near to each other. And similarly, some logic is talking to macro. What tool will do? Algorithm will do. It will take and it will place this logic near to the macro. And similarly, based on IO port communication, there is some logic which is talking to your IO ports. Okay, IO is nothing but input and output. So this logic is going to place near to IO ports. Okay, so when you are doing the placement, you basically do see two type of issues. So the first one is a timing, and second is a congestion. So there are a lot of ways to fix it. Okay, so we will help you in the lab to fix this, and then only we are going to proceed to the next step. Okay, and you need to make sure that all these cells are aligned properly to the placement grid. Okay, and these are the goals. Okay, so util jump should be very less. So whenever you say util jump is less, that means you are getting benefit in terms of area and there is no congestion. Okay, and no overlap or legality issues, and your timing number should be good. All these goals you have to meet. And this is the snippet from the lab after placement. So in IC compiler we have one feature like color hierarchy. So these all color, no? This belongs to one family and this belongs to one family and this belongs to one family, like that. Okay, so all these things will be done with the help of some set of commands. That commands we are going to put in this TKV file, and that we are going to source it. Okay, and the next one is the CTS. So what we have done till now at design import stage, you load all the inputs, and at forepan stage you have done the macro placement. At placement stage you have done the standard cell placement, right? So these standard cells include your sequential cells also, flops, let's say, right? You people all know that flop need clock signal. So that clock supply we are going to provide at CTS stage. So this will be going to happen with different topologies. Okay, so these are the basic three types I had captured. So not only these three, we have multiple, like we have fishbone, we have uh, H tree. Okay, when we have custom laptop. So this is the first one is the clock mesh, and this is a binary or basic clock to be called, and this is a spine structure. So there are different advantages. Let's say, for example, I was working on a AMD graphic chip. Okay, which is going to the desktop, not laptop. So I know it's always have continuous power, right? So power is not my concern, speed is my concern. So for that I was going to use clock mesh. And in other hand, I was working on a chip which is go to the some battery handled device like mobile or whatever. Okay, so their power is my concern, right? So I want to use the spine. So based on application, we are going to decide. Okay, so in the lab, what we will do, we'll define the routing tool, and we'll define the target insertion delay and target skew number, and we'll define which cells to use and which routing layer to use. So all these settings we are going to put in these tutorial files, and then we are going to source it. Okay, so that will do your CTS. Okay, so the next one is the routing. So basically, routing is a stage after we will after synthesis and optimization. So yeah, synthesis means clock to synthesis. So we have two synthesis. Okay, so before PNR you will do synthesis, and when you are having the PNR place and down, you have clock to synthesis. So here I told about two tickle files, right? In the first tickle file, we are majorly focus on skew and latency, and in the second one, we majorly focus on optimization. Okay, yeah. So and what we will do at routing stage? So we will based on netlist connectivity, so we will use some metals and wires. Okay, so with that we will connect all the pins. Okay, so this will be happen with four stages. Okay, the first one is a global routing. So what global routing will do, it will estimate the distance between two pins. Okay, like and the gate output is connecting to OR gate. Okay, it will measure. Okay, from here to here I have 20 microns. Okay, this is the Manhattan distance. And similarly, track assignment. Yeah. Here to here you have 20 microns and available track is M12 or M10. Okay. So that will be assigned by the track assignment step. And in detailed routing, what it will do? Okay. M10 was assigned for me or M12 was assigned for me. Let route in M12. So that will do detailed route or actual route. Whenever actual route is happening, so there is a chances. Okay. It will short with neighboring net or there will be some spacing violation. Okay, those things will be fixed by search and repair step. So it is an iterative process. So depends on your design. It will take around 40 iterations. Okay. So this is iterative process will take around 40 iterations to fix all your DRCs. Okay. And if you see in the lab, so there is a sanity checks you have to do. So you have to perform. So then only you can proceed out. Otherwise you will get lot of DRCs. So the very important command is check ZRT routability. So if you run this command, it will identify any blocked ports or the ports out of boundary and min grid violations and all. Okay, so all these things you have, it will report. If there is any violation, you have to fix it. Okay, if there is no violation, that means this is zero, this is zero, this is zero, then you are good. You can go to the route assist, sourcing this route assist.tickle. So that will complete your routing. Okay, so this is about the PD. Okay, the next module is the physical design verification or sign off. So once you've done the PNR, right? So you need to make sure that you have to sign off. Okay, sign off means you are going to validate all type of checks. The first one is a formality. So this formality is basically the functionality check. Okay, so it will generate two type of files. Okay, golden and revised. So both should match. If it is not matching, that means there is some change in the logic. Okay, if it is matching, that means formality is passing. Then you can proceed to the next. And LVS, layout versus schematic. If there is any opens and shorts, okay, in your design, so it will give some errors, you have to fix it. And DRC, so based on the foundry you will have some lot of DRCs. This DRCs you have to fix. Okay, and timing analysis, so it will directly impact your this both timing analysis and DRV, design rule violation, will impact your speed. If you fix all these timing violations and DRV, you won't see any issues with respect to setup and whole violation. Okay, the very important is IR drop analysis. So most of the time you see your mobile was overheating sometimes. Okay, sometimes even though you are not using your mobile, you can see your battery will easily dry out, right? So these reasons are majorly because of a poor IR drop analysis. So if you do proper IR drop analysis, no, you won't see these type of problems. Your mobile never overheat. Okay, and you can see if you're using mobile, then only you can see your battery will down. Okay, otherwise it won't. So all these comes under sign off checks. Okay, and the next module will be the mock interview and the personality development. So this module cover like resume building, like how to prepare your resume, that will help. and we'll conduct some mock interviews. Okay, so these mock interviews is very very important. For example, let's say we have conducted mock interview for one candidate and we figured out that this guy was very good at PNR, but he need to improve some HTS skills. Okay, so what we will do, we will add that guy into some additional classes, or we'll give some recordings to that guy. Okay, after some time like 2 to 3 weeks, again we'll conduct the mock interviews. So it will go repetitively, so that you will also get habituated to interview environment, so that whenever there's a client requirement, you can easily crack the interviews. Okay, and after course we'll conduct some exam also. And personality development programs. So there are few students, they are good in technical, okay, but they are not able to crack the interviews because of some lagging communication skills. For them, we will arrange this personality development program, so that it will easy for them to crack the interviews. Okay, so these are all about our uh, demo part, and let me know if you have any queries, so we'll discuss on that. You can use chat box also for the queries. Oh, which slide you want? I not seen the message. Okay, 10th slide. Okay, sure. So we are at 45. Okay, sorry. Guys, you can use chat box for any questions if you have. Okay. Oh, oh, oh. Okay. So yeah. So this is the 10th slide. Actually, it is a very important slide. Okay. Basically, I hope everyone was has concentrated on this, because so you need to understand whenever. Okay. So most of the people from recent college graduates, right? So you have to choose the right way. Okay. So don't choose the way only which is giving money, and don't choose the way only which is growth. Okay. You have to choose the way which is giving both, right? Okay. So that is very important. So do you have any doubts here? Okay, I think I'll repeat this slide. Okay. So basically, so these are the numbers, no, salary numbers. So this is the minimum numbers, right? So as a fresher, you can expect 4 to 6 LPA. Okay. So this much package you can expect. So once you join in a company, so after 3 years, so you if you be in the same company, you will get this much amount. If you want to switch, you will also get the product company offers. Okay. And these product companies, they will provide some along with the salary, they will provide stocks also. Okay. And after 5 years, you can see yourself as a team lead. Okay. And your salary will be 25 to 30 LPA. Okay. And after 10 years, you can see yourself as a program manager, a team manager, and your salary will be 60 to 80 LPA. Okay. So again, if you see the numbers, no, salary numbers, so along with the salary numbers, you will also feel that the job is very challenging. Okay, it's not like 9 to 6 job. So some companies there will be 9 to 6 job also, but it will be good if if you get the position which is very challenging. Okay, so 10.3. Okay, fee details you can get from the team only. Okay, so 10.3. So basically, 10th module itself is an physical design. Okay, this one, this one, 10.3 module you want. Rupasri, this one you want, right? You want to know about this one,
No, no, sir.
10.3.
Before slide.
Okay,
Channels
this one.
and all is there, na? That, no,
Okay,
not that before. Previous one.
this one,
No, 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 not that.
this one.
Channels and all will be there, na?
Yeah, this one, no? Channels.
Ah, yes, yes.
Okay. So basically, no, at forecast stage, what we will do. So these are the macros. Okay. So all these are macros. Basically, some these have some special functionality. Okay. So if you have our homes and all, right, earlier you used to use some different rams and everything, right? Now you can, if you want to extend your memory, okay, of your lab, you can get one hard disk and you can insert. Okay, so these are the rams basically we call. Okay, each has some special functionality. Okay, so basically by default at initial stage all will be like this at the 00 location. At 4 stage what we will do, so we are going to place like this. Okay, so while placing there is a connectivity also. Okay, based on file and connectivity, if you click on this, okay, so it will show the connectivity. So based on that you have to place, for example, these two macros was talking, these four macros are talking, so you have to place all four together. Okay, so similarly these macros are talking, you have to place together, otherwise you are going to increase the wire length. Okay, and coming to channel. Okay, so between one macro to other macro you have some space, no? So this space is nothing but channel. Okay, so you have to maintain proper channel. Okay, so if you not maintain the proper, this macro have some pins. Okay, so you have to maintain proper channel, then only you are going to give some space for the routes. Okay, otherwise you will see lot of congestion and all, right? So that's all about that slide. Any questions, any other questions? No one has any questions except Rupasri. Okay, so we have few more time, maybe. Let's see. Okay, so yeah, so these are the contact details. If you this is our Bangalore and Hyderabad office details. Okay, if you want to know any further details with respect to fee and when the batch is starting, I remember the batch is next batch is going to start on 11th, I think so. Okay, if you have any queries with respect to that, feel free to drop an email to info@sarshilavilasa.com, and you can even call to this number. Okay, even ping in WhatsApp also, 9742972744. Okay, so if no queries, okay, so we will close it here. And coming to Linux, no? Linux is basically a working environment. Okay, for example, how we are using the Windows, right? So if I want to download any file, I'll go to the files and then I'll download. And similarly I will do all these things, okay, with the help of the interface. Similarly Linux also, so there are some set of commands will be there. With the help of commands we will use this Linux. Okay, it's same as your Windows only. So Windows is a different operating system and Linux is a different operating system. So there you will do all activities with the help of commands. Okay, if you want to copy, you can use copy command. If you want to rename, you can use mv command. Okay, if you want to delete, na, you can use rm command. Okay, if you want to create the file, okay, so in Windows what you will do, simply you will right click and then you create a folder. So there what you will do, mkdir. So it's a different uh, operating system. Okay, everything will be done with the help of commands. Okay. Guys, we have some more time. If you have any queries, you can ask. If not, I was going to close this call now. Okay, I don't see any questions in the chat box also, except Rupasri. I don't have any questions. And there is a question from someone with respect to fee details. I don't know. Please connect with HR team. Okay. So yeah. So about EDA tools. Huh. So this EDA tool is nothing but, right. So our IC compiler. Okay, so this, okay, so guys, very important thing, as I told, na, we are going to provide this tool 24 by 7. Okay, if you go and check with the industries, na, so the tool cost itself per month there will be the industries, right, Synopsys and Cadence, so they will charge in terms of lakhs and crores. Okay, that much costly tool it was, so we are giving it access 24 by 7. Okay, so this EDA tool have lot of algorithms inside. So if you want to do place, you just need to run simple command like, okay, place opt. So for some of the bigger designs, place of command itself will take 3 to 5 days. That means it will place all the cells, okay, inside the core area. So according to connectivity, it will do lot of analysis. So these EDA tools are having internal algorithms. Okay, so based on that, it will going to perform if you run any command. Okay, okay then. Fine. There is a question. What is the main and basic subject learn physical design? So the very see, it doesn't matter like if you want to learn, right? You have, if you have interest, na, then it is okay. If you are good in electronics or if you want to learn electronics, it's fine. So coming to the basics, if you are good in CMOS and digital design, that is sufficient. And if you forget also, it is okay. In the first 2 modules, we are going to recall all the basics. Okay. Okay, guys. I think we are done here. Just stop recording. So thanks for joining on time. Okay. Thank you. Thank you all. Just stop recording.